All right, welcome. In this video, I'm going to be doing the solutions to BC review activity number 4. That's multiple choice with the calculator, and I'm also experimenting with new functionality of my document camera, so this should be plenty exciting, right? I am just now realizing, though, that I don't have the problems right in front of me, so I'm going to just have to grab those real quick. All right, now the first one I'm going to do is red star. Okay, so they give you a picture of a derivative. This is f prime, and it is looking about like that, where this is 2 and this is 4. Okay. So they're asking, where is f increasing? And this is pretty much a best case scenario, right? Because we know f increasing means f prime is positive. So I'm going to say f prime is positive from 0 to 2, and from 4 to this ends at 5. Okay, so 0 to 2 union 4 to 5. Okay, that one's pretty nice. I like that. Always got to get you started off with a pretty good one. All right, second one is going to be blue star. All right, let's see, move that down a little bit. So blue star is dy dt equals 6e to the negative 0.08 times t minus 5 squared. That's a little rough, right? But this is why it's a calculator section, right? How much does y change as t changes from 1 to, okay, 6. I thought it just cut off. Well, how much y changes is going to be the integral of dy dt from 1 to 6, right? Okay, you take the antiderivative of dy dt, that's going to be y of 6 minus y of 1. That's the difference in y as t runs from 1 to 6. So that's just what I'm going to do. I'm going to go over here. I'm going to use the calculator, fire it up, make sure I'm in. Somebody in my room has been changing the mode, right? I don't have any in-person classes this year that use degree mode. So what we're going to do is I'm going to say math 9. I'm going to integrate from 1 to 6 on, and since I'm only using this equation once, I don't need to type it into y equals 6e to the negative 0.08 times t minus 5 squared. Okay. dx. And then that's 22.583, which I'm sure is, that's answer choice D. All right. Number 3 is going to be yellow star. Okay, so move that down a little bit. Okay, yellow star is telling me f has the property that the limit as x approaches 1 from the negative side is positive infinity. Okay, that's it to keep track of. So I'm going to just kind of draw my axis here. As we approach 1 from the negative side, I'm going to infinity. So basically what I know is if this is 1, it's going to look like that. Okay. And then if as x approaches 1 from the positive side, I'm approaching negative infinity. It'll look like that. Okay. And the limit as x approaches infinity is negative infinity is positive 2. So maybe I'll just say that's here. And let's see, it kind of cut off for me. The limit as we approach positive infinity is also 2. So I don't know, maybe something like that. So I'm looking at what answer choice D, I think. So what's the difference here? No, it's C. Yeah, D is putting the vertical asymptote at x equals 2. I'm not really sure why. I think that we probably mostly got that one right. All right. Yeah, this looks like C. Now, number 4 is green star. And, well, green star is a question about average value. So the average value of f is equal to, you add them all up, integral from a to b of f of x dx divided by b minus a. So if we want to find the average heart rate, we're going to have to take the heart rate, integrate it, and then divide. And that's answer choice A. Okay, they just give you a bunch of other stuff that looks pretty appealing. And so, if we wanted the average value of h of t for t being between 30 and 60, well, that would be something over 60 minus 30. Well, the integral from 30 to 60 of h of t dt. All right. Number 5 is the Taylor polynomial one. All right. Let's see if I just hold on a second. Better. All right, so we know that the Taylor polynomial third degree around x equals 2 for a function f is going to be, all right, f of 2 plus f prime of 2x minus 2 plus f double prime of 2 divided by 2 factorial x minus 2 squared plus f triple prime of 2 divided by 3 factorial x minus 2 to the third. But I can just, read all these numbers off. F of 2 is equal to -1. I'm just looking for my eraser. Suspiciously got missing. Here we go. Oh, yeah, good point. Yes, this is purple star. I forgot to mention this is number 5, which is purple star. Thank you. All right, so they told us that f of 2 is equal to, what is it, -1. Told us that f prime of 2 is, what, 4? It's starting to cut off. The next one is going to be 6, right? Yeah, f double prime is 6. And f triple prime is 12. And then they're asking us to plug in 2.1. Okay, so I've got -1 plus 4 times 0.1 plus 6 divided by 2 factorial is 3 times 2.1 minus 2 squared is going to be 0.01. So plus, and then 12 divided by 6 is going to be 2. 2.1 minus 2 is 0.1. 0.1 to the third is 1/1000th. So 0.001. So this basically 0.432. -1 plus 0.432 is going to be like, I don't know, 568 or something. Yeah, that's answer choice B. All right. Let's see. Oh, number 6, I think that's one I can probably squeeze in right here. All right, number 6 is going to be red circle. So I'm going to let f be a function with derivative given by, okay, so they're going to tell us f prime of x, and then they're going to ask us about arc length. Okay, so f prime is the square root of x to the third plus 1. And what they want you to do is take the derivative and by hand and try to square it and put that into an integral or something. But we can do all this on the calculator, right? Because we know that length that they're talking about is the integral from 0 to 1.5 of the square root of 1 plus f prime of x squared dx. Right? This is a formula that we just have to know. Right? That's something that you can control is knowing the formulas that you need to know. And so I'm telling you, just know the formula for arc length. Right? It's one less thing to be worried about if you just know all the things you have to know. So, all right, I need a calculator. I'm going to type in, let's see what we got here, the square root of x to the third plus 1. And definitely don't need this. I need to integrate from 0 to 1.5. The square root of 1 plus f prime of x. I typed into y1, just making sure, yeah. Don't forget to square dy dx at the, and then that'll be 2.497, which, yeah, that's answer choice B. Okay. All right. So continuing to move along here, let me just get a different piece of paper underneath here. Oh, number 7 is, this is yellow circle, but this is one that I kind of need to print out, and I might need to zoom out a little bit. So, all right, let h be a continuous function of x only. Okay, that's what they mean, is like not a function of y, and not a function of x and y. Although, you might not know what a function of x and y is at this point. But what we have seen is we've seen dy dx equals x plus y. We've seen dy dx equals x minus y. We've seen dy dx equals y. And one of the things I told you when we were first starting to study slope fields was you need to make this decision based on, what does it depend on? So if they're saying it only depends on x, doesn't depend on y, when I change y, I had better not see a different slope, right? But over here, look, you go for here, it's negative, same x, different y's, now I'm getting different slopes, right? All the way down to here where it's positive. So it can't be this one. And if you look at all of these, right, just go up and down here, I'm getting different slopes as I change y. But this is saying it has to depend on x only, so it's that one. I think a better version of this question would have been, let h be a continuous function of y. Which of the following could be a slope field for a differential equation of the form dy dx equals h of y? I think that makes more sense to me. I think that you would catch more students knowing what to do on a calculus level. I think a lot of my people got confused just on what do we mean by h of x, right? They didn't tell me anything about h of x. It's that it doesn't depend on y. All right, so the next one is going to be green circle. And this is a good one. I haven't had anyone ask me about this one yet, but I'm kind of surprised. Okay, so for the green circle, we say f is a piecewise defined function. This would be a really good pre-calc question. I should have been asking. I asked this question a lot, grind through it algebraically. I never thought to have him do it calculator-wise. So it's k to the 3 plus x, and 16 over k squared minus x. Whatever. This is x greater than or equal to 3. This is x less than 3. These are two pieces of graph that, depending on k, is going to move them around. What we need is for it to be continuous. We need the two pieces to agree at x equals 3. So what I need is k to the 3 plus 3, right? Just replace x with 3, to equal 16 over k squared minus 3. And yeah, you could try to cross multiply and solve this thing, but you're going to end up with something that's 5th degree. And, well, you might not know there is no quintic formula. And even if there was, you wouldn't want to do that. We've got technology here. This is multiple choice with calculators. So what I'm going to do is I'm going to type in that equation. Except maybe I'll just say x to the 3 plus 3 minus this fraction, and I'll figure out where it equals 0. 16 over k squared minus 3. Now, what is the types of values I'm looking for? Okay, I don't really have any context, so I don't know what kind of k's or what kind of x's on my calculator am I looking for. But I'm going to look at the answer choices, and I'm going to say I'm seeing between 2.081 and 8.5. So I'm going to go set my window from 2 to 9. And I'm looking for where this thing equaled 0, so that's how I'm going to. Okay, that's once. I saw it. It was just after so it's got to be that 2.081, reasonably, right? So I'm graphing from 2 to 9, and I just saw it, the 0. Yeah, it's got to be 2.081.
Can I ask where, they're differentiable and continuous, you would take the derivative of both of them?
Yes, that is a common question, and I'm going to actually talk about that after there's this 2.081, just to make sure we got the right answer. So question from the crowd was, hey, if they'd asked where it was differentiable, we'd have had to do that, but also take the derivatives and set them equal. I have a feeling that it's going to be too hard. That's an interesting question. Because when you do that, it ends up coming back as a system of two linear equations, and I think that that's better for no calculator, because you'd have to solve twice. And it seems to me that on the ACE, you only ever have to like solve once on the calculator. That's an interesting question. I don't think that would come up on a calculator situation, but yes, the strategy is you set these equal to each other, then you take the derivative by taking the derivative of each piece and setting those equal to each other at 3, and then you'll end up with some kind of system of equations and get yourself an answer. All right. Number 9, blue circle. Really like this one. This one is new to me. I've never seen this problem before. I don't know how, but I really like it. I'm definitely going to use it in the future. All right, so this is blue circle. And, all right, so let f be a differentiable function. The figure above shows the graph of the line tangent. And I'll just kind of copy what the line tangent looks like. And pretty much, it's important that it goes like that. And that's pretty much all you can see. This is the tangent line. But what we know is, okay, that means that the curve is probably either like here, maybe something like that, or maybe down here, or maybe, who knows, I don't know. Maybe something weird's going on. But what I know for a fact is that if it's tangent at the point where x equals 0, and they told you that, that means that, f of 0 equals -2. But if this line is tangent to the graph of f, then the slope of the tangent line is the value of f prime of 0. So f prime of 0 is going to be, what was I thinking here? Oh, it's also -2 because it's the slope of this line, right? It rose -2 when it ran 1. Okay? And so f of 0 is equal to f prime of 0. That's one of the answers on. Okay, number 10 is purple circle. And this one, in the couple of classes that I have already had go through today, what did he say? Purple circle. The couple of classes I've had, this one was commonly missed. Much more common than I would have thought. So basically a referee is moving with v of t, and they call him a referee because it's on the soccer field and he's like running along the sideline. And I can envision that, the guy that calls the offsides, whatever, with the flag. He just runs back and forth on a straight track, like the particle motion problems in Calculus AB. I can't believe that I've never seen them use that before. And I feel like I just caught somebody that figured out what they did wrong. And that's good. If you already know what you did wrong on this one, that's good. So 4 times t minus 6 times the cosine of 2t plus 5. A strange function. But this is the type of thing, much like a referee in soccer is going to be running back and forth along the sideline following the action. This is going to go positive and negative because of that cosine, right? So what they're saying is from time t equals 2 to time t equals 6, what's the total distance? But we know one of the things that we just have to know about motion, which is definitely something we should add to our formula sheet. I'm going to just add that because I'm about to record on that too. Yeah, motion. I put parametric, but I didn't put regular motion. Okay, so that's something we can add to our formula sheet. Total distance is the integral from 2 to 6, just double checking that, yeah, of the absolute value of v of t dt. Right? Because everything needs to be counting forward. The referee is probably going to start off in the in the official's dressing room before the game. He's going to end up there after the game. But his legs are not going to be feeling like he totaled a distance of 0, right? We know that. There's going to be a lot of running back and forth. So we got to go over here. I think the trick on this one is just having the difference between the total distance and the displacement not being so far apart that, somebody might actually be convinced into choosing the displacement. All right, so math 9. 2 up to 6 of, why is the glare is, that only kind of helped. It didn't help at all with the overhead. It's because I just put it on the right side. So integral from 2 to 6, what is this total distance? Or what's the formula? I need an absolute value of 4 times t minus 6, that's times 4 times t minus 6 times the cosine of 2t plus 5. Strange function. or t is measured in minutes. All right. And we let it think for a while because it's the type of one that it has to think about. And we get that 21.667 number. Cool. Wonderful. We love it. All right, number 11. This is red triangle, and this is another one that I printed off a copy of just so that could look directly at the graph. Okay, you're supposed to, it's saying what x value gives you the absolute maximum of h on the interval -4 to 3. And h, we're looking at the graph of f, not h, and h is like an area counter on f. Okay, now let's think. It starts at 0, and what I'll tell you is that actually that doesn't really matter where it starts, because that's only really affecting if it's a polynomial, the constant term, or whatever the plus c is. When you actually find out, if you can find out what h of it is using anti-differentiation, then this bottom number is only going to impact the value of c. But let's see. All right, on one hand, I know that what you're supposed to see is that this area is much larger than that area, and then this area is also larger than that area. So what we're going to do is we're going to, if we start at -4, then it's going to be whatever h of -4 is. H of -2 is going to be less than h of -4 because I've accumulated all this negativity in what is the derivative of h, that's f. Then I'm going to go back up a little bit, to account for this positive area, but then I'm going to go back down a whole lot more. So the most I ever was over here at -4. But let's see. Maybe I can actually work through this one for you. So, all right. So the points that I need to be considering are the endpoints and the critical points. H prime of x is equal to f of x. Okay. And so h prime equals 0 when f is equal to 0 and x equals -2 and x equals 0. So what I need to do is I need to kind of just compare x and h of x. I need to consider the endpoints, -4 and 3. And then I need to also consider the critical points, -2 and 0. All right, well, 0, that one's easy. I like that one. Integral from 0 to 0, that is 0. The integral from 0 to -2, well, it's going to be the negative of the integral from -2 to 0, so it'll be -1. And then, let's see, that's going to be 1, 2, so I think that's going to be, wait, no, that's 1, and 3, it's going to happen. The integral from 0 to 3 is going to be negative. I can see that much, so that's not it. So I've got 1, 2, 3.5. And I'm assuming that someone would stop me in person. Is that -3.5? Thank you. Yes, that's crucial. The absolute maximum happens here, which is at x equals -4. That's probably the more process-driven way to show you. All right, moving on. Yellow triangle. All right, we can do yellow triangle, and I need to zoom back in. Yeah, there we go. That's a better level of zoom. Yeah, yellow triangle. All right, so the position of the particle moving the xy plane is given by the parametrics x of t. X of t is e to the -t, right? Yeah, mine got cut off, but y is sine of 4t. Okay, we know that speed is the square root of dx dt squared plus dy dt squared. Am I okay? Just barely at the edge of my shot. Okay, so if I want to find out what that is, at time t equals 1.2, I'm going to check and make sure I'm in radian mode because I am dealing with some trig here. I'm going to go bring in a square root. And rather than because again, this is a multiple choice problem, I probably shouldn't be using y1, y2 all that much. E to the -t, wait, I got a better idea. Let's take the derivative. Let's have it do that for us. Goodness, tough time here. Math 8, the derivative with respect to x of e to the -t. at the point where t is 1.2, don't forget to square it, plus the derivative with respect to x of sine of 4t. It's like, I know you know what the derivative of that is, but why even risk it, right? And then we're going to square that also. We are going to fire it off and get 0.461, which is, that's an answer choice. That's C. And it's the right answer. Cool. So, moving along. The next one, ooh, this one's very calculator heavy. And I'll be honest, I'm not sure that this is the only way or the best way to solve it, but it's all I've got. You know, as far as I know, you're supposed to use a calculator. There might be something better. I'll show you the fastest way I've got. All right. So let f be the function defined by, wait, what? Oh, green triangle.
Okay.
Yes, pardon me. This is the mean value theorem question, and, you know, it's just, okay. The f, I'm just going to type in f, and, okay, actually, I've already got it in here. So I'm going to show you, this was the one that I happened to use when I was showing somebody else how to do this problem earlier today. You'll see in y1 I plugged in f. f is 1/4 x to the 4th minus 2/3 x to the 3rd plus 1/2 x squared minus 1/2 x. It asks, how many times is the average rate of change equal to the instantaneous rate of change? Okay. So I don't know what the average rate of change is, so I go and find it. Average rate of change is just rise over run, right, on that little on that interval. Like, I know y1 of 0 is going to be 0, and I know that 1.565 minus 0 is 1.565. I was just showing them in class why I did that. And then I'm also going to graph the derivative of y1 because that gives me the instantaneous rate of change at a given time. And what I'm going to do is I'm going to check to see how many times do these run into each other on the interval 0 to 1.565. So let's just say, you know, we did that. Okay, that's the default y window. I'm going to change the x window, so I'm not going to look at stuff I don't know. Well, what's going to happen here is it's going to graph really slowly, but I think that this is actually worth it.
I did that same thing, but when I did my slope, I forgot to divide by 1.565.
Oh no, yeah, that's too bad. Okay, this is going to take forever. I'm not I can't turn on the fast graphing technique on these school calculators. But what's going to happen is it's going to be too near for me to see what's going on. And so what I'm going to do is I'm going to change the window to y running from -2 to 0. And that will really open it up. And so it's one of those, you know, there's 4 things that you need to be able to do with the calculator. You need to be able to run a numeric integral. You need to be able to take a derivative, a numeric derivative. You need to be able to solve an equation, which is something we did actually quite a while ago. And then you need to be able to graph a function on an arbitrary viewing window. And that's what I'm showing you how to do, is manipulate the window. Okay, so I forgot to push enter because this is going to take a long time to graph. What I'm going to do is I'm going to let this thing graph. I'm going to move on to number 13, and then I'm going to come back to this one and give you the answer. Wait, this was number 13. Wait, did I skip one?
I don't know.
My numbering's off because I did the one on the piece of paper. Yeah, so you don't even need to worry about the numbering, right? All you care about is the color and the shape, right? So 14 is blue triangle. And this is one that we should like because it's a logistic differential equation problem. Those are always pretty friendly. And it's just asking you which of these is the differential equation. It's the form of the differential equation. Like I told you, that's all you need to know. The form, the shape, and the special trivia fact. So they say the carrying capacity is 2,400. So, you know, we're just looking for dp dt is number times p times carrying capacity minus p. That's answer choice D. Move on with your life. Speaking of which, while we were talking about that one, it graphed, I see 3 intersections. So I'm going to say that's 3 times that the instantaneous rate of change, which is black, equaled the average rate of change, which is red. And I'm realizing that you probably can't see that on the recording, but that's okay. The flat line is the average rate of change, and then that's the instantaneous rate of change. If you've got a better technique, let me know down in the comment. Like, that would really be nice, but I've asked some people that are pretty good at this stuff, in my third period class, and they didn't have anything for me. So, all right. What else? Oh, number 15, and I really do like this one. It's purple triangle. It's the related rate problem. I thought this one was pretty good. All right, purple triangle. Okay, then this is the one at the annulus. That's what you call a two-dimensional donut. It's called an annulus. Okay, and their interest, and this problem was really poorly worded. I don't know that I've ever seen a College Board AP Calculus question so poorly worded. But we're talking about the shaded region throughout the whole question. That was kind of an issue for some people. It was like, what are they even talking about here? So they give you all of the pieces that you need. Okay, the outer circle's radius is increasing at 2. So dr dt, the large one, is 2. They tell you that dr dt for the small one is -1, and when the large radius is 4 and the small radius is 3, that's what they're interested in. Well, I know that the area of the annulus is going to be pi r squared minus pi r squared. Big one minus small one. So I can take the derivative of a with respect to time, right? That's going to be the derivative of a thing squared is going to be 2 times that thing to the first, maybe times the derivative of that thing with respect to time, if we're taking the derivative with respect to time, which we are. Okay, minus 2 pi r dr dt. And now I've got all the pieces ready. I just need to kind of put them all together, right? So what I'm going to do is I'm going to say dr dt, large dr dt is 2, r was 4, 2 pi minus 2 pi, this r is 3, and that's -1. That makes sense, right? Because the fact that this one is shrinking should be contributing overall to the fact that the shaded area is growing. And then, it becomes positive. 16 pi plus 6 more pi is 22 pi. That's it, okay? That was the multiple choice section with calculator. Okay, there wasn't that much that actually required a calculator. There wasn't that much, necessarily BC. I think those are a couple of comments I'd taken from people. The thing about the calculators, that's always going to be the case. You're not going to actually have to use a calculator for a majority of the calculator active questions. Right? It's not really a test of can you use your calculator effectively, it's how much calculus do you know. But then there's also the C topics thing. Well, first of all, 60% of your exam is going to be AB anyway, because that's just like the composition of the course. But then also regular series and to a certain extent some Taylor series don't work so well in a calculator setting. And so those are going to be more heavily represented in multiple choice no calculator, which is sometimes why y'all feel like multiple choice with no calculator is harder. But if we're seeing improvement from last time to this time, that's what we're going for at this point in the course, is that we're just trying to get better each time. So if you came in and you did the multiple choice with calculator today and now you're watching the solutions, you watched all the way to the end, you just got to be resolute in the fact that you are one day better at calculus. And we've still got quite a few more weeks before the exam. And so just stick with me and keep getting better day by day. And, well, there's nothing going to hold you back from getting credit in 3 or 4 weeks.